Hello, everyone who joined us on this beautiful evening. And today we are here with Node.js Event Loop conference. It's amazing to see so many smart and curious people who are interested in the same topic as we are. And this whole evening is going to be about Node.js. So I think it is important to understand why we decided to speak about it and why we think it's really important. So first of all, Node.js and JavaScript nowadays is everywhere. If you're working in the front end or in the back end, this language is everywhere. It's becoming more and more important for businesses every day since it's so versatile. Everyone can use it, and it becomes an irreplaceable tool for almost every business. It's also lightning speed. It's asynchronous and can be worked in a multi-threading fashion, as we will see in one of our presentations by our presenters. Also, it's lightweight, which is not something that every language can boast about. To compare it with other heavier languages like Java or C family of languages, it can be squeezed in places where others can't really be squeezed. Last but not least, since this language is so performant, no wonder this year it was selected as the most used language by the developers by Stack Overflow, which is not something that all languages have. And it actually means that even though it's not a new language, but it's going to be here for a long time. And we think it's going to be something that it's important to learn a thing or two about. Right. So we believe that this conference should be as much of a dialogue as it could be. So we have prepared the session of Slido app, and you can just go online. Sorry, is it visible? You can just go online or scan this QR code and enter into the session field "Tell us Softas," and you can enter your questions. And after the speaker will present his presentations, he'll try his best to answer your questions, and we'll see. Maybe something fruitful will come out of that. All right. So without further delays. Our first speaker is Guillermo Valencias. He's a senior developer and technical team lead. He has experience in several languages, Java, and now his primary language is Node. With his extensive knowledge and experience, he can actually compare several languages, and he'll show that today in his presentation about Node.js asynchrony, Libuv, and multithreading. So give a round of applause for Guillermo Valencias.
Yeah. Hello everybody. Hello to those who came here live and to those who join us online. Thanks Benas for such a warm introduction. I'm Giedrius, and I previously worked as a Java developer, but a couple of years ago started diving more deeply into the Node.js stuff. And oh boy, how many interesting things there are in Node.js. And one of those are asynchronity. Why it's important. In general, asynchronity is really broadly used paradigm in programming. So and Node.js has a particular set of rules for initiating this. So it is really important to know the pros and cons and certain aspects of a programming language, especially if you're starting to use it or already use it. So before further ado, let's begin our presentation. Right, so we're gonna do this like in a gym or like in a proper workout. Firstly, we're gonna warm up, remind ourselves about the basics of asynchrony, of JavaScript, a little bit about Node.js, and later on we're gonna start our workout. We'll talk about Libuv and working threads, and all proper workouts needs a cool down, so we're gonna summarize everything. Okay, let's begin. And I'm sorry, before that, I just want to remind you that there is a Slido that you can use and ask questions. And at the end of the presentation, if I will be capable, I'll answer them. Okay, let's continue. Okay, let's warm up. A little bit about JavaScript itself. Yeah, so JavaScript needs an environment that it could be running. Yeah, so typically very often we use a browser for that. Browser has this V8 engine that provides a runtime environment for JavaScript to run. It is initially implemented with C language. Okay, and it has two types of memory handling, and the first one is called call stack. This is the area where JavaScript running engine knows what kind of code will be running. It knows method frames, primitive values, pointers to the real objects. Okay, and it is known at compile time, so we know the size of it is known at compile time. So basically, before starting the application, it is already know what kind of size this call stack has. Okay, and we have a heap memory where it's more dynamic. It contains the real objects, functions, and yeah, basically it is pointed by the stuff in the call stack. And one important thing to notice there is that V8 engine has only one call stack. So meaning that JavaScript is synchronous. It can fulfill one thing at a time. Okay? Let's try to investigate it in action, how call stack works. Okay, so we have this really simple string fancifier where we put a stuff into our function, we add a prefix with fancy string and just print out. And yeah, how it behaves. So firstly, we start our main function, right? We put it in the call stack for execution. But firstly, we need to read through all the code. Okay, we add a fancy stuff into a call stack. Fancy print. Sorry, fancy print has a other method called make fancy. Add that too, and in the make fancy function we have instantaneously a return method with a fancified input. And from this part we're starting to eliminate stuff from the call stack and start executing it. We returned, fancified our input, put console log call into the call stack, and immediately it was executed. We have fancied stuff, okay? And continue until our call stack is empty. And this is a very trivial example how JavaScript works in the V8 engine using a call stack. And this is the place where we execute our stuff synchronously, okay? But what if we want to run multiple things at the same time? We want to call external APIs, we want to query databases, we want to read files and write to files, and most importantly, we want to wait for the responses in non-blocking manner. So meaning that if we query a database, we don't want to block our server, for example, if we implement a Node.js server, JavaScript-based server, we want other users to welcome and to not block them. Okay, so before diving in how we can do this in Node.js, let's remember what asynchronity actually is. Okay, so there is this multithreading concept where we have this processes that can run independently in the CPU. Basically, it's kind of an orchestration of app pieces that could work independently, right? So there is two flavors of multi-threading in the CPU level. We have this traditional one where for example, we have one CPU, and there's not a real multi-threading here, more like asynchronity, I mean, because it happens on a single CPU, and it's only a virtual multi-threading where we execute our program, but it's being executed basically synchronously in the CPU level, but it looks like it's being splitted into several parts, and due to CPU clocking mechanisms, it looks like it happens synchronously. And we have a situation where we have a couple of CPUs, and where we actually execute code in parallel. And most often these two styles are combined. Okay, so the thread itself, yeah, it's a small piece of a programming instructions that could be run independently from each other, and using CPU resources and operating with the same memory. It can write and read the same file, and this is where the problems could happen. Okay, so let's imagine a situation if one thread tries to modify a memory piece, a file, right? And the other thread tries to write into it, another thread tries to read from it, or two of them tries to write from it. So it could end up in corrupted data, okay? And to solve these kind of issues in traditional asynchrony, we use synchronized flags, for example, in Java, okay, to lock a resource. So basically we are giving priority to one thread instead of another, yeah. And this kind of situations could end up in deadlocks where resource is kind of blocked by access to the resource is blocked by several layers, and there's a queue of threads that waiting for it. Yeah, and thread monitoring and other issues. And basically, if we decide to implement a synchronous program that uses asynchronity, multithreading, it requires a really careful design and architectural decisions. So it's kind of tricky, and it could end up a lot of pitfalls. So, yeah. Another example could be a traditional server that, for example, runs some Tomcat on Java side, where we create a thread for every user request. So basically, there is a server which runs, right, and it accepts the requests. And if there is, a thread in the thread pool, it takes this thread, assigns it to the request, and executes the code. So so basically a thread per user. And typically scalability in this kind of servers are being achieved by increasing the threads number. Yeah, more threads, more more racing issues where we could encounter deadlocks and stuff like that we discussed before. Okay, what about Node.js? Firstly, let's remember what Node.js is. Yeah, it's an open source, cross-platform, backend, JavaScript runtime environment. Pretty similar as in browsers, where we execute JavaScript code, but Node.js itself, it's kind of designed to allow developers to develop servers, not front-end applications. And it's same V8 engine, but outside the web browser. And we previously talked about how JavaScript is synchronous. It runs on a single thread. It has one call stack. And how about Node.js? So answer is yes and no. Tricky, right? But hold on. So yes, it's that in the sense that it still has one call stack. It can execute synchronous stuff in the call stack. And no, but it allows execute a CPU-intensive work without blocking code in a call stack. So it can behave asynchronously. And I guess, most important question here, can we support server-like applications without necessity of maintaining those threads, those asynchronous issues that we saw before? And the answer is yep, we can do it. Okay, so how we can execute asynchronous code in a single threaded environment? Okay, so with this slide, the warm-up is over. We can exercise now. Main workout Libuv. What is it? Libuv. Again, it's a C library originally written for Node.js to abstract non-blocking input-output operations. Kind of dry sentence, but I'll try to explain it. Basically, Libuv helps us with operating with the file system, with the streaming, networking, stuff like that, HTTP requests. But it allows for operating system to handle these things on the background, and JavaScript itself doesn't do this stuff. It runs on Node.js, and Node.js has support for Libuv library, so it's built-in stuff into Node.js. Okay, Libuv has this thing called Event Loop, which is in a nutshell a single thread which loops all the time and listens for the incoming requests. If, for example, it's a server, a Node.js server. It waits for those requests, registers them, and gives all the work for the Libuv library, that OS stuff to communicate with file systems, HTTP requests and stuff like that. And in the meantime, we can execute a call stack. Synchronous stuff, while Libuv handles all the synchronity. And we have this thing called event queue. What is it? Basically, when we assign a blocking tasks to the Libuv by event loop, we create these things called callbacks. And when the synchronous stuff is done or failed, for example, we put a callback into the event queue for it to be executed later. So basically, it's an indication that something happened with the asynchronous code. Yeah, I talk a lot about callbacks, but okay, what are they? We're gonna use an example with FS library. It's a built-in Node.js module which allows interaction with file systems. Okay, so this is how it would like if we try to read a file, a grocery list, for example, and assign a callback to that read file method. Okay, so this is a callback. So basically, a callback is a function like a contract which will be executed only when the read file method is complete, failed or succeeded. Okay, so often it is sometimes it will be a misunderstanding if often by the junior developers that this callback thing is a code that will be executed asynchronously, but it's not true. Asynchronous stuff is only here. This is only the one place where the Libuv takes action. It communicates with operating system, reads file, and has this contract with our JavaScript code through Node.js that please Libuv let us know when you're done and allow us to see the output of this code when you're done. So this callback. So this is synchronous code that will be put into the call stack and executed synchronously. Okay, more advanced example of fancifier, but this time using Node.js. Okay, so what I added is the only thing here. It's the same example as we saw before, but this time, in addition to printing out the fancified input, it saves the input into the file.txt file. Okay, so let's see how it behaves. So yeah, we have this event loop which listens all the time when Node.js started. We start by executing our main code, let's put it in the call stack. Then we have our fancy print stuff. We instantaneously go inside of it, add to file, and this is the place where the magic starts to happen. To file, calls write file method, Libuv under the ground, and when we start to execute it, it puts the write file request in for the Libuv to complete. But since it's not the work of the call stack, we can remove it from the call stack and start executing what is the remaining stuff in the call stack itself. We can go to the fancy input, put the console log into the call stack, print that out as previously, empty our call stack, okay, and we're kind of done here, but still event loop, still loops. There is this one single thread that listens for the call stack queue. And at some point of time, Libuv will complete its job and write input into the file. And as we talked before, there is a contract called callback that will be registered into the callback queue, put into the callback queue. And event loop, as I said, iterates and listens if there is something in this queue. And if there is, it puts it into the call stack. And we can start executing it and print out that file is saved. And this is how we empty our call stack and our application. Yeah, so we just saw an example with a file system, this built-in Node.js module file system. There are other things that we could use for these non-blocking operations. This is a HTTP built-in module for communicating with server and client, creating a client. Also, we have a support for cryptography. Okay, but what about other CPU-intensive tasks? For those who are not related with file system, HTTP, cryptography, for example, if we want to implement something in the pure JavaScript language, and we don't want to block our call stack, something serious like calculating sand grains that are in a bucket. Okay, look at the quotes I added, not very serious. Okay, but it could happen. For some reason, we could want to implement a very CPU-intensive function that uses JavaScript code that's not supported by these Libuv magics. Okay, so this is a very simple code which iterates through the it has a loop, while loop, it iterates 10 billion times and just prints out that, yeah, I'm done. It's trivial, but it could block our call stack because it could take some time to be executed, for example, at 10 seconds. And 10 seconds in server is really huge number, right? If we block our call stack for 10 seconds and the server cannot fulfill incoming requests for 10 seconds, it's bad. So, okay, so what if we really want to use multiple threads with Node.js? Okay, we need to put this non-blocking JavaScript code into threads for really to be unblocking, right? Okay, so our next main workout will be our working threads. What are those working threads? Before identifying what they are, let's remember how asynchronous is being handled in a traditional manner. So yeah, threads created in traditional manner has this thing called shared context, where we need to control race conditions that could result in corrupted data. Racing conditions. The example I used when I spoke about writing into the file and reading from the file, where we need to lock certain resources so that they could be prioritized for certain threads. Okay, worker threads modules basically don't do that. They don't have concept of shared context here. And trying to implement multi-threading without breaking the JavaScript laws. Basically, multi-threading is not being implemented in the JavaScript language like we have a Java or C. And how does that? So yeah, the main thing is that workers, the threads, runs in complete isolation. Okay, when we create a thread in Node.js, we run it in isolation. And threads itself, a parent thread, the code that creates a child thread, can and vice versa can communicate with these called channels, message channels, by serializing data. So basically, if threads want to communicate, they make copies of data. So there is no real race conditions to solve. How does that? So yeah, each worker, each thread in this situation has its own V8 engine instance and event loop and Libuv support. So basically a little small environment for thread to run in isolation. Yeah, and as I said before, parent worker and child worker can communicate via these messaging channels. And for example, said that, yeah, parent, I'm done. Okay, okay, child, take this data and execute it. And when you're done, inform me about it. But yeah, we have message channels. Okay, let's go back to our sand grains calculation example and try to put it in a worker thread. So put it in the service.js file first, okay, and add some source to it. What I did there is just added a built-in working threads import, and instead of printing out the console log message, I added this messaging channel call that I mentioned before for informing the parent worker about completion of this code. So basically, whoever executes this code creates a thread out of it will be informed via this message channel that this thread is done. Okay, we need a code to execute this child. Let's create a parent. Import a working thread in the parent as well. There is this run service. It just popped out, but yeah, stay with me. It's nothing really fancy here. We just create a new promise. Inside of promise, we create a new worker instance by pointing to the code that is in the service.js file. And the working data parameter is input to the child worker to work with. Okay, and in addition to that, we start listening for the events that will come from the child worker. So in this case, we're going to listen to the message event, and the message event will be fired when the child, basically informs something through the messaging channel, and it prints out that the child is done. And we, in addition to that, we're listening for the error event. If something unexpected happens, it just rejects the whole promise. And there is this little piece of code to execute the run service. Okay, let's try to see how it would look if we start it in the console. So we have this main application indication that it's starting a worker, and it actually starts the worker with the input one bucket. That would be our volume where we calculate our sand. And instantaneously after that, we're gonna do something really important. In this case, we just blah blah blah, doing something fancy. So if we start to execute it, application instantaneously start the worker and start the run service. And instantaneously it prints that they are doing something fancy. In the meanwhile, run service calculates these sand grains, and we are kind of unblocked in the main thread, in the parent thread, and we can do other stuff in a blocking manner. And some point of time, the child will say that I'm done. So so this is how we could implement the CPU-intensive task writing the pure JavaScript code, and it is allowed by working threads module. Okay, that was some stuff that we discussed. Let's summarize it. Okay, so Node.js have this call stack where we can execute a blocking code. Single thread, one item by the time, and if it has a call for the library, it just assigns it and continues. And so library, this C library that is that supports input and output operations as HTTP requests, file modifying files, reading from it, and cryptography and stuff like that. And it put the callbacks back into the call stack for execution via callback queue. And we talked about this working thread module. which allows to execute a CPU-intensive tasks in writing the real JavaScript code in complete isolation of a thread, where we not necessarily need to deal with all this multi-threading complexity. Okay, and one bonus point that if we need a lot of this kind of CPU-intensive tasks in Node.js, so that I guess we need to consider if it is a really good decision, because Node.js is basically built for handling input and output operations, and we need to be focused on Libuv stuff and take advantage of it. So if we're planning to use something for crypto mining or stuff like that, I guess we should consider the programming languages as well. And I guess that's it. Thank you for your attention.
Thank you for the presentation, Giedrius. And we have quite a few questions. So I quite liked your framework warming up, so I have warming up question for you as well. So first question, why Node.js were called language?
Why it's called language?
Yeah, because there is a JavaScript and there is Node.js, and everyone's calling JavaScript a language. So why do you think Node.js is a language?
Well, it would be more accurate to call it a environment where the actual language is being executed. Okay, so I don't know. Well, actually, I think it's because it feels like a new language. I guess it has a lot of built-in stuff, and a lot of people use it for server development. I don't know. My honest, I guess, answer is that it feels like a language, and stick like that.
Okay, awesome. All right, the next one. How big the Node.js team in Telesoftas? Does the team embraces TypeScript for projects?
Node.js teams still in recent years we grew a lot. I don't know the exact number, but I would say about 30 or more people now developing using Node.js, and we enforce, we respect the TypeScript. It's kind of good tool for controlling to keep a control in teams. I believe that if we use a JavaScript, is kind of good. Pure JavaScript is kind of good for prototyping things, and TypeScript allows to control, to have saved knowledge for the types that are used in the project, so that we avoid some problems, compiling errors with the new features. So in an Node.js platform, we have this thing called platform. We respect TypeScript.
All right, great answer. Thanks. The next one, is it possible to use async await syntax instead of callbacks?
Instead of callbacks. Well, in a nutshell, we're still gonna using callbacks. We're gonna promisify something inside a code that will be executed asynchronously. But the real callback function, I guess in a visual manner we can avoid writing that. But still, we have a callback running somewhere in the background. But from controllability reason, I believe yes, we can write pretty well readable code with async and await stuff. So my answer, I guess, would be yes, but we need to think about that callback that still there are somewhere.
Yeah, I guess you can feel the trend that everything is moving towards the async await syntax, but that's definitely a part of what it is. And the last of the hard questions, what were the biggest challenges, pitfalls when developing solutions with Node.js?
So I guess one of the recent issues that we encountered was streams, where we need to pipe things from one stream to another. So there was some some stuff to debug, and yeah, it's sometimes complicated to test these things. So streaming knowledge and piping and all this stream transform stuff is a really good thing to focus on when we want to learn more about Node.js, how useful it is. And yeah, I think streaming, piping, these are the hard nuts, I guess.
All right. That's nice. I think we're going to have a presentation just about that. And for the cooldown, it's not actually a question, more of a statement. It says, Giedrius, best wishes from your classmate Ignas Tonys. Raseiniai loves you. So,
Thank you very much.
Thank you, Giedrius, for the presentation. So now we're going to have a short break of around 7 minutes, and we'll be back with you shortly. Yeah. Keep up with it. Thank
Hello, I'm Paulius, a full-stack software developer at Telesoftas.
Hey, I'm Robertas, and I'm a backend engineer at Telesoftas.
We received a fishbowl full of questions from you about Node.js, and today we will be answering them.
So let's get started.
Right, let's start off with the first question. How would you describe Node.js to a person who has not used before in a couple of sentences?
Whoa, that's a really nice question. I would go with single sentence. I would describe Node.js as a asynchronous, non-blocking, modular environment for executing JavaScript code outside of the browser.
Well, that sounds a bit complicated, but that's basically what it is.
Yeah, it is.
I have a question.
So what's coming next? Does Node.js have any limitation? If it does, what are they?
Well, while Node.js has a lot of pluses, I think there are some limitations too. And probably the biggest that comes to mind is the limited multithreading support. So, while there is workarounds such as workers, there is really better alternatives when there's a need for CPU-heavy tasks. So I think that's probably the biggest drawback to using Node.js.
Yeah, that's some good points. I would totally agree with you.
Alright, well, that's good. So, tell us how Node.js is used at Telesoftas. What are its main purposes?
Oh, we use Node.js in a variety of different industries. For example, splitting music royalties, or building big e-commerce solution, or even building some leisure management systems. So we have a lot of different projects which are using this technology in a variety of different fields.
Yeah, and Node.js really is spread out across multiple projects and maybe not just one niche.
Yeah, it is.
Right, Writable.
What's coming next? What languages do you have to know, or what platforms do you have to be familiar with in order to start learning or working with Node.js?
Yeah, that's a good beginner question. Well, while there are multiple languages that Node.js supports, in order to start learning or just get into Node.js, I think, JavaScript knowledge is sufficient enough to, just to get into Node.js. And, you can pick up more languages as you go. There's also, it's easier to get into Node.js if you already have some back-end experience or some, with other languages, so it's easier to transition than start anew.
Yeah, that's some really good points. Grab a bowl.
I don't mind if I do. Right, who's the most advanced in Node.js at your team, and how long has he or she been working with Node.js?
We have a joke inside our team that the most experienced person is the one who has the biggest beard. However, I would answer this question from a more serious point of view, I would say that each of us have different skills, and the combination of those different skills, what makes us as a single, united, senior, mechanism.
Right, really, it's the team together that makes up the experience.
Yeah, exactly.
Right, go ahead.
Okay. How do you learn Node.js at Telesoftas?
Well, learning in Telesoftas is a big part of our expeditions, and probably the biggest thing that comes to mind is the constant knowledge sharing sessions, such as workshops or presentations, or just getting together to code something like a little side project. There's also a lot of internal documentation that we have, such as best practices that we note while developing or making some projects, so that everyone, no matter what their level is, can just read up on some topic that they're maybe lacking of. And also there's also the human factor that whenever a person has a problem, he or she can always reach out to the rest of the team and just ask in the channel. So I think those are the main reasons how we learn.
Yeah, I also love the fact that we have 4 of project hours which we can spend for our own education and growing.
Yep,
which is really nice.
Yep, as long as you have some goal and you're even encouraged to spend those hours. That's
yeah. Grab a ball.
Okay, that's it. Okay, that's the first one. So, how many people are there in the Node.js team at Telesofts?
Currently, we have more than a dozen Node.js developers who are working in different projects across different teams in Telesoftas. However, we are constantly growing and we are always seeking for new kolegučiai, so...
Yep, always looking for the talent. Right.
What's coming next? So, what do you like about Node.js the most?
Probably the fact how easy it is just to write asynchronous code, because there's a lot of tools that Node.js provides us, such as most popular ones are maybe promises and the async await thing to just to manage our asynchronous code, because if not kept properly, it can become a really big mess if not managed correctly. So I think that the fact that Node.js provides us with those capabilities is a really big plus.
Yeah, I like the fact that you can write asynchronous code in multiple different ways. That it makes language really sexy.
Yeah, you can see that. Right. Almost the last one. So, is Node.js flexible? What kind of software can be developed with it?
I would say that it's super flexible. You can use Node.js for building backend applications. For example, HTTP servers. You can even build gRPC servers, MQTT servers, or front-end application. You can even use this technology for building software for embedded devices. So I do believe that it's a really flexible language for a variety of different purposes.
Yep, whatever you can think of, there's probably a package for it, right?
Yeah, exactly.
Okay, do you believe that's the last question?
Yeah, the last question. What can it be? How can people apply to work with us at Telesoftas?
The last question is also the easiest one.
Yeah.
All the info you can find is
over there.
Welcome back to Node.js Event Loop conference. And without further delay, we're gonna move on our next presentation. So next presenter is Robert Daskalskas, who is really knowledgeable developer and overall really enthusiastic person. Today he's gonna present us a complex topic, as we heard from the last presentation, about Node.js streams and some practical examples, how can we use them and make our code a little bit better. So give a round of applause for Robert Daskalskas, and the stage is yours.
So, hello everyone, my name is Robert Daskalskas, and today I'm going to do a presentation about Node.js streams. So, generally, why streams are important? As my beloved colleague Giedrius has mentioned, we need to run code in a synchronous manner. Due to this reason, we should care about reading from files as well, especially in the cases when we are dealing with large files or large database tables or some heavy data sources which we're interested in. So, without further comments, let's move forward. So I will begin this presentation from the introductions. So in the introductions part, we are going to discuss what is the stream. So we will just look through the definition, what is the stream. Later on, I will try to compare streams with some more natural examples, which we find in real life. Further, we will investigate different types of streams, and we are also going to investigate why do we use streams in overall manner. Last but not least, we are also going to look through where streams are used in Node.js at its core. So let's move forward. So what is the stream? According to the definition, the stream is a fundamental Node.js feature, or in other words, data structure, which helps us to read data from a really large data source in a sequential manner. Boy, this definition sounds complex. We could look into an example which you can see in the right. I have made a diagram in which you can see three different types of streams. So at the top of the diagram, there is a readable stream, which by itself says that it reads input. Later on, that data chunk by chunk is moved into some sort of fancy transformations, which we are doing in our business logic. And after those fancy transformations, our transformed chunks are being moved to writable streams, where it is being written to our destination source, which can be a file, a database table, or some sort of other destination. I always find these definitions quite hard to understand. Due to this reason, I would like to compare streams with nature. So imagine that the big data source is a ocean or a sea, and in the sea there are a lot of water, which means that you could not process all the water which is inside the sea in a single time. In order to feel the sea or get in touch with sea, we can imagine that the tides or waves which are coming from the sea to the coast are the buffers. So the sea is transmitting us a chunk of itself by tides and waves, and all the obstacles which tides or waves encounter during the traveling from the sea to the coast are the transformations. So those transformations can be rocks, can be pressure differences inside the ocean, or other things. And once the wave or a tide reaches the coast, it becomes different looking from perspective, looking from a point of view how it began. So once it hits the land, it's totally different piece of information in comparison with the start. So let's move further. I do believe that this explanation is more understandable than the pure definition. So there are generally 4 different types of streams which you can encounter. So as I have mentioned, those types of streams include a readable stream. So by its name, readable stream is used for reading data from a large database table, from a large file, or a generator function by sequential manner, which means that we are not reading all the contents at once. We are reading that content by allocating a fixed amount of memory in our operating memory. And once that memory is being read, we are removing that memory, and thus our application consumes way less memory than it could use. Further, we have a transform stream. So transform stream is interesting in the manner that it accepts a data from a readable or another transformable stream, and it can transform, or in other words, mutate the buffer which comes into the transform stream, which means that we can receive a one type of a chunk in the input part of a transform stream, and we can spit out totally different data structure or modified data structure in our output. Moreover, we have a writable stream. As the name mentions, writable streams, our main focus is to write data which we are receiving into stream to an external data source, file, or a table. And we are doing those writes in a small pieces, which means chunk by chunk. For example, the same way we are charging our batteries in our phones. Once we plug a phone into the socket, we do not see that our phone has charged immediately to 100%. We see that the phone is charging, which means that the charge is coming from the socket into our phone, chunk by chunk, little by little, and once it reaches a sufficient capacity, it charges our phone in general, and we reach 100%. And last but not least, we also have another type of stream, which can be, which is called Duplex stream, and Duplex stream is really important because it's a combination of readable and writable stream at the same time, which means that we can think of a Duplex stream as a stream which has a portion of functionality of readable stream and a portion of functionality of writable stream. As I have mentioned, streams are really really good way to streams are generally really good way to asynchronously read sequential data, and in order to read sequential data in a good manner, streams are based on event emitters, and as you can see in the slide, streams has got a lot of internal events which can be subscribable to. I have made a table where you can see relations among different streams and how those streams shared those different events. So each different stream has an event of closing, an event of data once it receives data, an event of end when there is an end, an error when an error occurs, and a readable, resumable, drain, finish, pipe, and unpipe. The one thing I want to mention, which is really interesting, are the two events which are called readable, which are called pause and resume. In case we have differences in our system on how fast computer can read data and how fast it can write data, we can get into conflict of back pressure. For example, if we are reading data faster than we are capable to write, we need to make some sort of pauses while reading from our source prior to writing to the destination, because otherwise our buffer, which stores all the chunks, will get clogged. Moving further, these are the examples of Node.js internal libraries where streams are used at its core. So we have a module which is called process, and the process has three different areas where it spits information. So we have a standard input, which means that if we are writing, let's say we are having a terminal application and we are writing some data into the process, we can read that data. Once process absorbs that data, it gets spit out that data in standard output. And in case if there is an error during the process, some sort of error message could be spit out to standard error, and it can be done as a piped stream. We also do have a module which is called file system, which was mentioned by my colleague Giedris as well. And file system module has several helper methods, such as create read stream and create write stream, which helps us to write and read from our files which are in our file system in a streamable fashion. Moreover, we've got a socket structure in net module, which is one of the core things of HTTP servers and TCP communications between different processes as well. Moreover, we are using streams in archiving. For example, Node.js internally has a library which is called zlib, and zlib has several different functions such as gzip, create gzip, create gunzip, and others in order to take a bunch of files and archive them in a asynchronous, non-blocking way. Last but not least, we have a lot of useful functions in crypto library as well, which we can use in order to cipher the information we are designing to cipher. So let's summarize this section. Why do we use streams in general? I do believe that using streams are really efficient, looking from both a memory point of view and time point of view. Since we are processing things in small chunks, the things can be done parallelly, and those small operation does not take that much time as the operations which are occurring when you are reading from a large file and everything at once. Also, this approach is highly composable and efficient strategy in case you are doing some heavy lifting. For example, you are reading some different files from some cloud provider, let's say S3, Amazon S3 bucket, and at the same time, while you're reading those chunks, you are archiving those chunks and you're putting that information to different bucket and so on. Using streams in these operations are really efficient. So moving forward, let's overview how streams can be created. And in this section, I will show you how we can create a readable stream, transformable stream, duplex stream, writable stream, and we were also going to overview how can async generators can be combined with stream pipeline. And I will also mention why we should use some of Node.js internal provided tools for piping a lot of streams together. So let's move on to the creation of readable stream. So let's start from the top. First of all, in order to create stream, we need to import original class of readable stream, which we can do from my stream Node.js library. In this example, I will also use a random bytes function from a crypto. Moving forward, there is a function which is called data generation. And data generation function is a generator. As you can see on the line number 4, function notation has an asterisk, or in other words, star, which notes that this function is not a simple function, but it's a generator. Moving further, we have a simple logger. You will see this logger in other slides as well. It just takes a message and console logs with a prefix in case of info and with a prefix in red in case of error. So let's move on the stream itself. So we are creating my custom readable stream in this example, and in order to create custom readable stream, we need to implement _read method. The _read method is a core method for a readable stream. However, it also has some other important methods which can be implemented, such as _destroy, etc. So what we are doing in this example, we are defining a chunk and we are saying that the chunk is an iterator result of a string. And we are checking whether our data generator has a next value, and if and we are assigning that value to a chunk, and we are also checking whether the chunk is done. And in case the chunk is not done, we are also checking whether stream allows us to push a value. Why it's important to check this .push function in a while loop. It's interesting. Streams, while using this .push notation in a stream, it returns a Boolean value. And in case there is a back pressure and the second stream cannot accept more buffer at this current time, this .push function returns a false statement, which means that we can do a short pause between the reads in order to unclog our further streams and make them run efficiently. So in this example, we are just generating random bytes, and we are converting those random bytes to hex. And if you are curious about the result, it's really fast. If you would go through this example on your local machine, you could see that your terminal is going like crazy. So what is being done? So we are generating a random hex string of 8 bytes. And we are writing that, we are reading that from a generator, and we are spitting the logs into our console. And it can go forever, which means that things we are reading are not being put straight into our operational memory. Once it's read and it's not being used, the buffer is being drained, and we can proceed with further data. So let's move to the further examples. So creation of transport stream. You can see that the example is basically the same. The only difference is that we are importing transform class instead of readable class from a stream library. And we are creating different type of transform stream. So in this case, we are creating a stream which takes a buffer and returns buffer as base 64. So basically what it does, after taking a chunk, it converts it to string in a form of base 64. And after the mutation, we are taking the value of that base 64 string and make a buffer from it. In order to make the console log printing prettier, I also put a end of a line at the end of the push. And it's important to call back after you're doing the push. The callback indicates that you are done with the chunk, and the Libuv library, which my colleague Giedrius has introduced you before, deals with that callback in a separate native thread. In case you are curious of an example of this stream, so once we write, let's say, word welcome, we get a base 64 string of word welcome. In case we write 2, we have another base 64 string. And you can see in this example, welcome Node.js Event Loop. I hope that you are having great time. So let's move with the example of Duplex stream. So what is a Duplex stream? As I have said, Duplex stream is a combination of a read and write stream. It's really interesting because Duplex stream can have either one data source or it can have multiple data sources, dependent on the implementation or what you are trying to achieve with the stream itself. A great example of Duplex stream is a WebSockets. WebSockets do accept client connections in the server, and the clients itself do also accept messages from a server itself, which means that we are having a two-way non-blocking communication using events during which we are sending buffers of data which can be interpreted and used in our business logic. Moving forward, example of Duplex stream. So as you have seen this example of Duplex stream, its main purpose was to emit a message of ping. And that readable stream shared same data source. So once it receives a readable stream of ping, a writable part of Duplex stream catches the chunk, and it writes another chunk of message which transforms the word ping to pong. That's a really simple example. I just want you to know, to get familiar with Duplex streams. So moving forward. Last but not least, writable stream. So in case of a writable stream, everything is the same. We've got a writable class. We have a writable options in case we want to extend our stream with some extra fancy typing. So in this case, I have made a type which is called prepend input writer options, and it expects prepended value as a string. So we are creating a prepended input writer which extends writable, and that in comparison with others, this class has a constructor. And that constructor is a combination of aforementioned writable props and that type which I have created on my own. So since we're using in these examples the inheritance principle, we need to call a super method where we pass the options. And we also need to define prepend value, which is mandatory in creation of the class. We have a underscore write function, which has a method, which has a property of chunk, which is a buffer. Also, it has an encoding in case we are curious what type of encoding our writable stream is receiving. And we, as previously, we have a callback, which in case of error supports an error object, and it returns void. So we can, prior to writing, we can also do some transformations if you wish to, or we can just send this file, for example, to another stream or to a file which we could open using underscore constructor, and we also would close it with underscore destroy method. Unfortunately, the capacity of slides are really limited. Due to that reason, my examples are quite short. Moving forward, this is example of writable stream which I have showed you just recently. So in case we are inputting some of text into our standard input, we are prepending the output with some sort of value. So in this case, due to the fact that we are created class with the word prepended, we are prepending this word next to the input which we have provided to the standard input. Moving forward, this is really interesting. So it's possible to combine both streams and asynchronous generators. What does that mean? So generators itself are not a streams by itself, which means that they do not have events which can be subscribable. However, internal tool which is called pipeline supports asynchronous generators as well as streams to compose a pipeline. So we can safely use, for example, a readable stream and a asynchronous generator for data transformation all together. And in this example, I have made a pipeline of 3 composed asynchronous generators. So the first generator is used for generating a sequence, and the function which creates a sequence accepts 2 parameters. So the first parameter is limit, another parameter is throttle in milliseconds, and we are creating a number of integers, and we are sleeping for an amount of time in milliseconds which we have provided in function definition. Further, our data is being processed by a function which is called powerify. So what powerify function does, it takes a chunk which is of type number from a previously executed generator function, and it powers the value of that chunk by a power of 2. And further, it yields the result back to the further stream. And lastly, the last stream, or not the stream, but generator, is a function which is called stringify. It accepts a stream, and it also iterates through the streams as a chunks. And during each iteration, it converts chunk to string, and for better visibility, it just prepends a end of a line after the iteration. So using async generators pipeline. So in case we are using this example, we could expect something like that in our results. So we have an initial value of 15. Let's say our further stream takes our powerify async generator takes a chunk. It powerifies that chunk, and our stringified value also takes the same value and just prepends an end of a line to that value. And this concept can be composable, which means that we can put as many of streams as we like in our pipeline in order to efficiently solve our problems or do things while we are iterating through data step by step. Things to be aware while using streams. It's useful to know that you should always use a pipeline instead of a pipe in order to avoid data leaks. Why is that important? In case you are using .pipe notation on a stream, you should explicitly handle an error on each stream, which means that you should subscribe on error to each different stream and have a separate error handler to each stream. And in case you are using pipeline as utility, which comes from Node.js core, you can put all those streams in one place, and you can handle errors in more centralized way, which means in a one asynchronous block, which could later on switch error based on your application error code, let's say so. Moreover, it might be quite tricky to write unit tests for streams. In some cases, it can be tricky, but in some cases, it can be beneficial. For example, if we are dealing with pipeline, it's useful to it could be useful to mock a pipeline utility by itself in order to check whether all the streams which are being passed to the utility are of the shape which we are willing to receive. And we could also mock the writable part of the stream, which usually interacts with some sort of cloud provider, as I have mentioned, AWS S3 bucket. We could mock the writable part of the stream in order to write the same output which we would write to S3, but we could write that output to a local file and check whether our implementation works end to end. Moving further, practical examples of using streams. Well, these examples will be kind of pseudocode, but I just want you to get to know streams better. So let's move on. In this section, we are going to talk about external data streaming from process to standard output, but in validated fashion. And we are also going to cover a really simple PDF generation from some sort of external data source. So moving forward, let's start from a runtime standard input data validation. So imagine a case where we have where we expect an input from a standard input, and that input can be anything. We can write any nonsense which we want to the standard input. However, if we introduce a generator, let's say, which in itself has a validation schema. In this particular example, I'm just using a third-party library which is called Joy in order to do a validation. And we are validating whether our input into the standard input is one of those three words which are mentioned in the screen. So those three words are help, run, or stop. So these are only three valid commands which are being supported by our stream, and in other case we are just returning another value which is also yielded as a buffer. So looking from example point of view, in case we are writing some sort of illegal command, let's say so. Let's say we are writing telesoftas instead of a help. So our standard output would yell at us by saying that the word telesoftas is not supported, and the only supported values are help, run, and stop. So moving further, we can use streams to generate things which we are transform. So in this example, I hope that you can see quite well, we are creating a readable source, which is an infinite generator. That infinite generator does a task every 1000 milliseconds because we have introduced a sleep function there. And what's happening every second? We are fetching some sort of data from an external API. In this particular case, we are fetching a random user profile from random.me API, which I do believe most of us are familiar with for mocking. And later on, we are yielding a buffer from that received data to the further streams. Please take a note that we are stringifying this data structure in order to push it as a string. Later on, this chunk reaches another function, which is called make PDF. And you can see that this higher order function accepts an instance of a browser, which means that it's a higher order function, which returns a generator itself. So in this example, we are using a browser instance, which is Puppeteer. It's widely used for end-to-end testing of front-end applications. However, in this particular example, we are going to use it to render a PDF document. So what we are doing, we are generating a constant of data. We are parsing that chunk which we have yielded in the previous stream. And once that data is parsed, we are reading a file which contains our handlebars template, which will build a HTML portion of our PDF. We have a compiled handlebars template, and we pass that parsed data to the template. And once the data is passed to the template, it's being rendered as a true HTML with those variables which we have received from an external data point, and we can set that content to a opened browser page and take a snapshot of the PDF itself, which can later be stored or moved to the another stream, depending on our needs. And the end result of such example would be like a quite simple user card, which represents our logo. You can see that some random person, which is called Devran Tivinkel, wants to join Telesoftas. I bet that it's a good decision. And I bet that you have already read why it's a good decision to join Telesoftas. So without further notice, let's move further. So final thoughts. I do believe that promises synchronous stuff, which my colleague Giedrys has mentioned before, are a really good combination altogether. We should care about our single thread environment in Node.js, and we should try to execute as much of asynchronous code as we possibly can. So, and if you are not using streams really often, I highly suggest you using those more often, especially in ways when you are dealing with files, archiving, or cryptographically encoding some data inside files, etc. So, have you got any questions?
All right, thank you very much, Robertas, for a presentation and quite a deep dive into streams. I guess a lot of us learned something new today about that. So, a couple of questions from the audience. The first one, you mentioned Puppeteer. Don't you use Cypress for end-to-end testing yet?
Yeah, in front-end developer, people are using Cypress. Speaking about myself, I'm a back-end developer, so end-to-end testing is not my engine, let's say so. I usually do a lot of unit tests, a lot of integration tests, but not like end-to-end testing of the browser. But I definitely believe that Cypress is a better choice to do end-to-end testing because it's a framework to do that thing.
Yeah, fair enough. It's quite similar, but they both have different stuff as well.
Yeah.
So I guess that's a good point to settle on. People noticed that you were using generators, and there is one question about that. What is the difference between yield and await? Because they seem quite similar, but they quite a different thing. Maybe you could expand a little bit about how they differ.
Yeah, so the yield works kind of different because we are yielding once there is a value. It's kind of hard for me to explain like in depth because it's a really, really deep topic about generators itself. Generators itself are really interesting, and at the same time they are tricky. And in these particular examples, we were dealing with asynchronous generators, which means that those generators also can run asynchronous code, which is being put as a callback into Libuv, and it also can yield those results back to the further transformations or further processing. I hope that I have at least covered something from this question.
Yeah, it seems like it's a totally different concept. Await is more for handling asynchrony, and yield is for working with generators.
Yeah.
Yeah. All right. Right. What are your personal or Telesofta's in general thoughts, attitude towards functional programming with JavaScript or TypeScript?
What are my personal thoughts on functional programming? I do believe that people should not stick to one concept. Generally, programming language is a tool, and we usually solve business problem. You do not need to focus on one portion of paradigm. For example, you cannot tell that it's a right way to code everything in functional programming. At the same time, you cannot tell that it's a only good way to code things in object-oriented programming manner. I do believe that the combination of the tools which language gives itself and the choice of software engineering makes a really good end result looking from business point of view.
Yeah, I would add that just people who are coming from different languages also shapes how we actually do, and there is no actually that much of a strict rule.
Yeah.
Right, so the last question, do you use Lodash or Lodash/FP?
I try to avoid like heavily bloated frameworks, not frameworks like utilities for doing some manipulation. Of course, those are tested, but at the same time, it can give us some tangled dependencies of different versions across different services. Nowadays, people are working in microservices environment, which means that we need to maintain a lot of different services at the same time, and it's quite hard to maintain same versions of libraries among those different servers. So I use third-party tools only when I see a necessity of using those. And in case it's really simple, it can be written in plain JavaScript, and it can be easily unit tested, and it works straight out of the box.
Yeah. Okay. Thank you very much, Robertas. That was the last question. So thanks for deep but at the same time simple presentation, and we'll move on.
So thanks to you all. I hope that you have enjoyed this presentation.
Right, so now we'll have a couple of minutes break, and we'll be back to you shortly. Bye. Šiaip, kažkaip neužlepino ant galo, gražiai. Welcome back to the last part of Telesofta's Node.js Event Loop conference. And now we have our last but not least speaker, Antanas, our freshly baked technical team lead of Node.js. And he's quite an experienced guy, has more than 9 years of experience in Node under his belt. He is, I would say, pretty cutting-edge personality. And we'll see that in his presentation about decorators and the TS39 proposal for Node.js language. So give a warm round of applause for Antanas, and the stage is yours, Antanas.
Hello everyone here. Hello everyone watching remotely. Yeah, my name is Antanas. I've been working in the industry for over 9 years. I've been working with Node.js on and off. I actually started working with Node.js when it was just recently released. I think it was like version 1.0.4 or something like that. Yeah, so anyway, it's getting late, and without any further delay, let's get started. Before I begin, I want to point out a couple of things. Even though I will be showing examples in TypeScript, and it might be obvious for some, but decorators are not TypeScript-specific feature. It's JavaScript-specific feature, and yeah, you do need since it's not yet released and it's a proposal feature, you do need a transpiler like TypeScript or Babel to use it today. So yeah. And another interesting thing about decorators, that something similar to decorators actually exists in other programming languages as well. For example, PHP have annotations, and actually since PHP 8 it was renamed to attributes. Java have annotations as well. Python has something which is also called decorators, which serve a similar purpose. C# and Rust have attributes as well. Even these things are called differently. They have different APIs and work slightly differently. They serve the similar purpose, which I will try to explain. Anyway, actually, and yeah, and some of these languages like JavaScript didn't have them right from the beginning. For example, Java, I think, got annotations since version 1.5 or something like that. Yeah, so okay, now that I got that out of the way, let's talk about decorators in JavaScript and TypeScript. First of all, what is a decorator? A decorator is a form of a higher order function, which is a function that takes a function as an argument and returns a function. But if that would be only the case, you could use decorators only with functions. And that's not the case in the JavaScript. You use decorators with classes and class properties, class methods, etc. So yeah, but as I mentioned, and I will repeat myself probably a couple of times, decorators are just functions. And it's easy to understand, well, it's important to know that it's just a function, because at first it might look a little bit intimidating, but if you think about them as just functions, it gets easier to understand. So simply put, decorator is just a function that wraps a piece of code and adds additional information or modifies the behavior of that code. Right. In JavaScript, decorators have special syntax. They are declared as functions, but you also can declare them as factory functions. The difference between the two is quite obvious. The factory functions accepts additional arguments that later can be used in the decorator logic. And also, you call decorators by prefixing them with @assign, and you write them above the code that you want to decorate. Yeah, and also another thing to point out is that factory decorator approach requires you to add parentheses. That's actually something that I prefer to use because it implies that it's just a function. So now that we know what decorators are, the question is, what can we do with them? And it's a complicated question. There are many use cases, and you can think of your own use cases. Anyway, in JavaScript and TypeScript, decorators allow adding additional information about the code, and in some cases replacing the behavior, or actually adding the behavior, modifying the behavior, or replacing the behavior of a code. And I also could compare decorators to object-oriented decorator pattern, but the difference between the object-oriented decorator pattern and decorator as a language feature is that in the object-oriented pattern you decorate object instances, and in case of decorators you decorate classes themselves and add additional behavior, dynamically to them on class level. To further understand what can you do with decorators, you need to know that there are several types of decorators in JavaScript and TypeScript, and they have different capabilities. First, there's a property decorator, which is used to decorate a class property, and it allows observing and adding additional information about that property. Then there's Accessor decorator, which is used to decorate a class property getter or setter. And similar to property decorator, it also allows observing and adding additional information, and it actually allows modifying the behavior of a getter and setter. After that, there's a parameter decorator, which is used to decorate class method parameters. And once again, it allows observing and adding additional information about that parameter. There are slight differences between JavaScript and TypeScript decorators, and this is one of those differences. JavaScript doesn't have parameter decorators available today, and to use them, you need to use TypeScript. But spoiler alert, that might change in the future. Then there's a method decorator. Personally, a method decorator is the most interesting decorator from my point of view, because it not only allows adding additional information about a method, but it also allows modifying the behavior of that method. And lastly, lastly, there's a class decorator, which primarily is used to associate metadata, and well, it can be used to modify behavior of class, but mostly it's used to add additional information about that class. And you probably noticed that I was naming these types in a sort of weird order, and that was intentional because that would be the actual order of how decorators would be executed in the runtime. And I've copied this example, this actually quote from official TypeScript documentation page, and it tries to explain the sequence of decorator execution. And it also mentions that you also can decorate static properties and methods, and they would be actually executed after the instance properties and methods. And the class decorator will always be executed last. There are a couple of things that I still need to mention about decorators. One of those last things is about types, and the decorator is not tied to the context that it's decorating. So you don't necessarily have to use different decorators for properties and methods. You can write universal decorator that will work on either property or method, but the difference will be the arguments that the decorator function receive. So you could write something that checks what kind of arguments the decorator function are receiving and base your logic on that. And I've already mentioned that decorators in some cases allow modifying behavior of code, and this is achieved with property descriptors. And what is a property descriptor? A property descriptor is a JavaScript object which is associated to every single property of an object. And there are two types of property descriptors, a data property descriptor and accessor property descriptor. The difference between the two is that the accessor descriptor would be available for the getters and setters of an object. Yeah, so simply put, property descriptor is an object that is associated with every single property of an object, and it allows you to inspect and modify behavior of that property. Last thing about decorator types is that you can actually compose decorators, and you can use them. You can use multiple decorators on the same class, same property, same method, and they would be executed top to bottom, but the logic would be evaluated bottom to top. So that's similar to function composition in math. So hopefully by now you have a rough idea what decorators are and what can you do with them. The key points that you should understand about decorators are that it's JavaScript feature first. You can use them today, but you do need a transpiler like TypeScript or Babel. They're similar to annotations and attributes in other programming languages. They're just functions, and they also can be declared as factory functions. They are called with a special @assign prefix and can be used to associate information and modify the behavior of a code. They can be used on classes and class members. And lastly, they receive different arguments based on the context that they decorate. I will now go deeper into each type of decorators, and we'll show you a couple of examples. Let's start from the class decorator. Class decorator receives a single argument, which is a class reference. And a class decorator, as already mentioned, can be used to associate additional information, which is called metadata, about that class and actually modify the behavior of that class. And let's look how we could do that. For example, I created a decorator which decorates a class, and it receives a class reference, and it returns an extended version of that class with additional log tag property. So you can imagine that you can dynamically modify classes like this. However, there's a slight issue with this example, and that's due to how TypeScript works. Since the property is added dynamically, TypeScript compiler would not be able to see it. You can work around it by casting to any type, but keep that in mind. And that would not be the case in JavaScript, since in JavaScript you wouldn't know the type of a class anyway. Right. Another example of class decorator, and this is maybe more interesting. You can actually access class prototype in a class decorator and modify every single method, for example, in that class. And this is what I did here. So basically, I took a class, I iterated over its prototype methods and replaced them with a different definition that adds additional logging logic on top of it. So you can imagine that you could write class decorators that replace the need for many lines of code in your program, which would make it more readable and less error prone. Yeah, that's cool. Another type is property decorator. Property decorator can only be used to observe or add additional information about a property. Property decorator receives two arguments, which is a target, that is a class definition, class reference, a property key, which is a property name, and there are actually difference between JavaScript and TypeScript decorators in a way that JavaScript decorator would also receive an additional property descriptor. Right. Property decorators can only be used, as I mentioned, to add additional information or observe that property, and they are not that interesting by themselves. But I still thought that I need to make a valid example of how could you use them. So, for example, here I created a decorator that takes a format string, which is additional information, and assigns it to that property by using class prototype. And yeah, you can see that later you can access that additional information in a print method where you can apply it in your logic. And yeah, once again, I will mention that in my opinion, there isn't much use of a property decorator without reflection and metadata, which I will talk about a little later. Then there's Accessor decorator. Similar to property decorator, as I mentioned, it can be used to add additional information about that property. It actually receives three arguments: a target, which is a class definition, a property key, which is a property name, and a property descriptor, Accessor property descriptor, which can be actually used to modify the behavior of a getter and setter. Yeah. And another thing to point out is that since getter and setter of the same property is actually kind of the same property, they share the property descriptor. That's why there's a limitation that you can only decorate either the getter of the same property with a single decorator. Yeah, and I've created an example here of Accessor Decorator, which adds additional logging logic on getters and get and set methods by using a property descriptor to replace the get and set methods with a version of those methods that have that additional logging logic. Yep. Then there's this one of more interesting decorators, a method decorator. You can, as I've already mentioned, you can use method decorator to replace the logic of a method, and that's done in a similar fashion like I showed you with Accessor Decorator, where you use a property descriptor and access value property of that property descriptor object and replace it with a different implementation of a method. Right. So I thought that there could be a more interesting example with method decorators. So I created this. Imagine that you have a business logic that throws some business-related errors, but at the same time you need to expose HTTP errors. However, you need to transform those errors to appropriate HTTP serialized errors. For example, it should have probably a status, a message, and something like that. And you wouldn't want to expose a stack trace or something like that. So you could create a switch error decorator, which takes one error and another error as an arguments, actually error types, and wraps the method in a original method in a try-catch block and calls the original method. And in case of an error, it checks whether the error matches the instance of a given type. And if it is the case, it would transform it to that to-type error. And this way you could do something like this, where you write your business logic, you throw business-related errors, and transform them to appropriate HTTP errors. Let's get to the parameter decorator. Parameter decorator, as I've already mentioned, is only available in TypeScript now. It receives 3 arguments: target, which is a class definition, class reference, property key, which would be the method name that the parameter decorator is used, and the parameter index, which would be the index of the argument in the method. Right. So you can actually, and this is one of those examples that you can actually combine decorators. And even though, for example, parameter decorators or accessor decorators aren't interesting by themselves, you can achieve interesting results by combining them with, for example, method decorator. So in this case, I've created a parameter decorator which basically just assigns additional information about that parameter using the class reference. And later I can access that information in a method decorator which wraps around the original method that I decorate and checks whether the given argument is null or not. And in case if it's null, it can throw an error. So it can result in something like this. And as you can see in the example on the right, where you could write clean and simply to understand validation logic. Right. I've showed you some examples of how can you write your own decorators and what can you do with them. I showed you that you can combine decorators to achieve some interesting things, but let's talk about what's already available. So decorator feature is quite popular actually, and it's already widely adopted by some libraries and frameworks. For example, TSED and Node.js are full-featured application frameworks that are built around decorators. There's also Angular, a front-end framework which uses decorators. And there are quite a few libraries like Class Validator for validation, TypeDI for dependency injection, and so on. So in summary, you can actually find already written libraries for most of your use cases. So you could easily use decorators in your projects right now. And here's a couple of examples of how those libraries and their decorators look like. As you can probably notice that, for example, TSED and Node.js are quite similar. And Class Validator gives you ability to decorate your class properties and validate them. And yeah, TypeDI, for example, gives an easy way to create dependency injection. I will show you one more example, but before that, I need to explain a few more concepts. And those concepts are reflection and metadata. These are quite complex topics, and you could probably make a talk just about them, but I'll try to explain it to the best of my ability. So I would explain reflection as a programming language ability to intercept, inspect, and modify behavior of a code in the runtime, and metadata as data which is associated with that code. And combining these two concepts, you can achieve something which is called metaprogramming, which is a very powerful technique where basically computer program can change itself in runtime. Yeah, an interesting fact, actually reflection was natively available in assembly language right from the beginning, and later it was lost with the introduction of C language, and then later introduced with more higher level languages again. So JavaScript has this reflection API already available today, and it provides method that allows you to intercept JavaScript operations. I hope you can see it. I wanted to fit everything in a single slide, so I had to shrink down the text, but I hope that you can see it. But anyway, reflection API allows development of programs and frameworks and handle code dynamically. Right. And metadata, metadata is actually another proposed feature like decorators, and it's not natively available today. And it adds on top of the reflection API by providing additional methods to work with metadata. And it also, the proposal also suggests that the actual every single object in JavaScript should be extended with metadata property and metadata methods. Right. So this is my more advanced example. I try to keep it simple. But basically, I've created an inject decorator, which will take a key, and I will be using it to decorate a constructor parameter and assign additional information about that parameter using reflection API. And later, I will be accessing that information in a container, which is basically just a class with a couple of methods, and that contains a list of, actually a map of dependencies. So by using inject method, I push that dependency into the container, and by using resolve method, iterating over those dynamically assigned properties about that parameter and try to resolve the dependencies like that. This is really simple example, and you should probably do some validation and checking whether the type matches, etc. But this shows that you could easily achieve dependency injection with decorators, and it would look really clean in actual code usage. So yeah. So this is sort of end of my presentation regarding decorators. However, there's still one topic that I need to talk about because decorator feature depends on it. And this is ECMA and TC 3090, which stands for European Computer Manufacturers Association, and Technical Committee 39, which is a working group of ECMA organization. So ECMA organization is an organization which standardizes IT systems, and one of those standards is JavaScript, which the TC39 group is responsible for maintaining and evolving. So, and features like decorators and metadata that want to be added to the language need to go through these 5 stages of official process. So first stage is stage 0, which is just an idea that gets suggested to the working group. And if the idea is good, a formal proposal is formed, and it reaches stage 1. At this point, a group is formed, a group of people is formed, and a leading person is assigned. Usually the leading person is the same person that suggested the idea. After that, they start developing their proposal, and and once they're done with that, once they document everything, implement everything, make tests, example implementation, it reaches draft stage. And after the testing and sort of a cool down time, if everything is working fine and there's nothing that needs to be added, it reaches stage 3, which is candidate, basically a release candidate. And at this point, it's safe to say that the feature is going to be released at some point in the future. Actually, it should be said soon in the future. Yeah, and then the stage 4, which basically means that the feature is done and it can be started to implement in languages like actually language engines like V8 and etc. So, and I've marked these stages in a red and green zones. And that's to emphasize that actually, while the feature is in the red zone, it's an experimental feature, and it doesn't mean that the feature. It doesn't actually mean that the feature will eventually be released. It might as well get cancelled. So why am I talking about this? That's because it happened, and every single example that I showed you in the Decorator API is not going to see the day of light. Yeah, so they changed the standard, and no worries, it's all for the better. And the legacy proposal, which I showed you the examples, is still recommended, since there are actually no way to test the next proposal version, as there are no transpilers that can do that today. So yeah, and another interesting thing about this new proposal, if you look at the API, it has get metadata, set metadata methods. And as I've mentioned that, for example, in case of parameter decorators and property decorators, there isn't much that you can do with them, and you do need to use metadata to assign additional information about them. This version of API has methods built in for that. So let's speculate what can happen in the future. So since the reflect metadata proposal is really tied to the decorators, I would assume that it will be released first, or it's going to be released together. There's another concept that is in the works, which is called decorator extensions. And for example, like I mentioned, parameter decorators, which are not yet available in the JavaScript, it could be by using extensions. And actually, TypeScript has plans to implement this new decorator API in their roadmap. So we should probably see this new API available to play around with in TypeScript probably next year. And taking into account how many libraries have been built around it, how much time companies like Google invested with their Angular framework, and how people are adopting decorators, I would bet that it's going to be released anyway. So, yeah, any questions?
Okay, well, thanks a lot for your presentation, and for sure we have some questions. So, first one, a little bit theoretical. So, how to become a tech lead? which should be something interesting for you, since not sure if everyone knows, but Antanas here is our brand new Node.js team tech lead.
I guess you just have to be interested in what you do. I mean, that's basically it, I guess. If you're really interested, it doesn't actually mean anything when if you become a tech lead. You just love what you do.
All right, best wishes. I hope you'll enjoy this role. Right, are decorators often used in telesofts, and which methods are the most popular?
Yes and no. I mean, we have a project that we heavily use decorators there because we actually use the Node.js application framework. So yeah, we use it heavily. Although we try to keep it within, I mean, common sense. And for example, we don't use decorators in our business logic. But yeah, we do use them, even though they are considered experimental. Well, not considered; they are experimental.
Yeah, no. Yeah,
We're on that kind of bleeding edge.
Yeah. Right. Last one, Fastify or Express, more commonly used under the hood with Node.js by Team Telesoftas?
Actually, for now, we're using Express, but we are considering switching to Fastify. And it actually, by using something like Node.js, it shouldn't be a problem. I mean, just a couple of, just change the packages, and that's kind of it.
And which one would you prefer?
I guess I would, if I had to choose, I would probably prefer Fastify.
Fair enough. Okay. Last question for a cool down. Do you rap when you are not coding?
No. No.
All right. Thanks a lot for the presentation. Yeah. Thanks.
You're welcome. And actually,
Antanas.
yeah, thank you. And I have actually a couple of things to mention. We're hiring, and if anyone is interested in joining Telesoftas, you should be able all our available positions in Telesoftas website. And we also will start internship, Node.js internship next year. So keep that in mind.
Right. Thank you. Right, so we did actually get a request that people are interested in the snippets and the examples that today presenters showed. So you can find all of the presentations in our social media, in Facebook and LinkedIn, if you are interested and want to get a refresher. And without that, that was our last presentation. Hope you learned something new today, and hopefully see you next time. So, bye.